4 years ago, humanity got its first look through the most powerful telescope ever built. Now, to mark that anniversary, NASA has released something extraordinary. Not a new discovery in some far corner of the universe, but a brand new look at a galaxy astronomers thought they already understood. And what it reveals has scientists calling it one of the clearest, most detailed views of a galaxy ever captured. This is the story behind Webb's newest, most incredible images yet. If you love deep dives into the universe's most jaw-dropping discoveries, hit subscribe now because we break down NASA's biggest releases every single week. Let's start with the anniversary itself, because it's worth understanding just how far this telescope has come. July of 2026 marks 4 years since the James Webb Space Telescope's very first images were revealed to the public, a moment that instantly reshaped what astronomers thought was possible. In the years since, Webb has peered further back in time than any instrument before it, studied the atmospheres of distant exoplanets in unprecedented detail, and captured images so sharp that scientists have described its performance as better than anticipated year after year. To celebrate this 4th anniversary, NASA chose a subject that perfectly demonstrates everything Webb has learned to do, a galaxy called Centaurus A, located somewhere between 10 and 16 million light-years from Earth, depending on the specific measurement method used, making it one of the closest active galaxies to our own Milky Way. Here's why scientists chose this particular galaxy to showcase Webb's full capabilities. Like this video right now, if galaxy collisions and black holes fascinate you, because Centaurus A has both. Centaurus A owes its strange, distinctive appearance to an ancient galactic collision, a merger between two separate galaxies that occurred roughly 2 billion years ago. That collision didn't just reshape the galaxy's structure. It supplied an enormous surge of gas and dust, fuel that has driven intense STR formation ever since, and fuel that continues feeding the supermassive black hole sitting at the very center of the galaxy. As that black hole consumes surrounding material, it powers what astronomers call an active galactic nucleus, a bright, violent central region that blasts out powerful high-speed jets of plasma extending far beyond the galaxy's visible boundaries. That combination, an ancient collision, an actively feeding black hole, and a galaxy still forming new stars from the aftermath, makes Centaurus A what scientists describe as one of astronomy's most important laboratories for studying how galaxies, black holes, and star formation evolve together over time. Don't forget to subscribe before we get into exactly what Webb saw that previous telescopes couldn't, because the difference is remarkable. For decades, astronomers have studied Centaurus A using multiple different telescopes, and each one revealed only part of the picture. The Hubble Space Telescope, observing primarily in visible light, produced stunning images of the galaxy's outer structure, but its view is fundamentally blocked by a thick, warped lane of dust running directly across the galaxy's center, the enduring physical scar left behind by that ancient collision. NASA's now retired Spitzer Space Telescope was able to see through some of that dust using infrared observation, revealing the galaxy's larger structures, but its resolution wasn't sharp enough to distinguish individual stars within that densely packed central region. Webb changed that completely. Using two of its most powerful instruments together, the mid-infrared instrument, known as MIRI, and the near-infrared camera, known as NIRCam, Webb was able to pierce directly through that obscuring dust lane, revealing details of Centaurus A that no previous telescope had ever captured. In the MIRI images, scientists can now see intricate filaments, loops, and glowing clouds of warm dust stretching across the galaxy's center, along with reddish, purplish points of light marking dust-rich stellar nurseries, regions where older stars are shedding material back into space, while entirely new stars are actively being born. Here's the part that genuinely surprised scientists. Make sure you're subscribed, because even NASA's own researchers admit they don't have all the answers yet. Buried within the MIRI imagery, astronomers identified a curious, unexplained S-shaped feature within the galaxy's dust structure. Nobody currently knows exactly how it formed, or whether the actively feeding black hole at the galaxy's center played any direct role in creating it. It's a genuine open question, sitting right alongside some of the most detailed imagery ever captured of this galaxy. A reminder that even with today's most advanced telescope, some structures in the universe still defy easy explanation. That's not the only mystery Webb's new data has revealed, but it's paired with genuine answers as well. Using its combined instruments, Webb detected fast-moving ionized gas being pushed outward from the galaxy's center, most likely driven directly by the black hole's intense activity. The data, also, revealed warmer molecular hydrogen gas arranged in a warped rotating disk near the galaxy's heart, offering scientists new, direct evidence of exactly how a supermassive black hole reshapes the material surrounding it over time. These observations matter because they let scientists directly trace the black hole's influence, rather than simply inferring it from indirect evidence. watching ionized gas accelerate outward in real, measurable detail, and mapping the shape of a warped hydrogen disk close to the galactic center, gives researchers a genuine physical picture of the ongoing tug of war between a galaxy's gravity and the enormous energy released by its central black hole. It's also worth understanding why Centaurus A specifically was chosen for this milestone anniversary, out of everything Webb could have pointed its instruments toward. Because it sits relatively close to Earth in cosmic terms, astronomers can study its individual features, its dust lanes, its stellar populations, its black hole activity, in far greater detail than would be possible with a more distant galaxy. That proximity, combined with its dramatic collision history and active black hole, makes it an unusually complete case study containing almost every major process astronomers care about within a single, relatively nearby system. Perhaps most remarkably, in the combined NIRCam and MIRI image, what initially looks like simple visual grain or texture is actually something far more extraordinary. It's a densely packed field of individual resolved stars, each one a real distinct point of light within Centaurus A's crowded central region. Being able to resolve individual stars this far away within a region previously obscured by thick dust gives astronomers what they've described as a form of galactic archaeology, allowing them to reconstruct a rough timeline of the galaxy's history. Which stars formed first? When star formation activity slowed? Which stars were born specifically during the burst of activity triggered by that ancient collision? And which stars formed even later from gas stirred up in the collision's long aftermath? Sean Donegal-Goldman, Division Director for Astrophysics at NASA headquarters, described the significance of combining these different views by noting that no single telescope ever tells the complete story, explaining that discoveries build over time, with each new observatory expanding on the foundations laid by the instruments that came before it. That sentiment captures exactly what makes this 4th anniversary release so meaningful. It isn't simply a new, beautiful picture, though it certainly is that. It's a demonstration of how far observational astronomy has advanced in just 4 years, transforming a galaxy that earlier telescopes could only partially explain into a richly detailed, still evolving scientific record. One astronomers can now study star by star for the very first time. Alongside the imagery, NASA also released new video content built specifically for this anniversary, taking viewers on a visual journey through Centaurus A's dusty structures, its glowing star-forming regions, and the complex energetic environment surrounding its central black hole. Researchers have also connected these new observations to a broader body of published scientific work, including new preprint research and peer-reviewed studies, specifically analyzing how this ancient galactic merger continues to influence star formation and black hole activity billions of years after the initial collision occurred. For scientists, this anniversary release represents far more than a celebratory image. It's an active, ongoing area of research, with astronomers already working through the newly resolved stellar data to refine their understanding of exactly how galaxies like Centaurus A evolve following a major merger, and how the relationship between a galaxy and its central black hole continues shaping that evolution long after the initial collision fades into cosmic history. Let's take a step back and look at Webb's broader 4-year track record, because Centaurus A is really just the latest entry in an extraordinary run of discoveries. Since its first images were unveiled in July of 2022, Webb has fundamentally reshaped astronomers' understanding of the early universe, capturing light from galaxies that formed just a few hundred million years after the Big Bang, galaxies so unexpectedly massive and bright that they forced scientists to reconsider existing models of how quickly the first stars and galaxies came together. Some of these early galaxies appeared so mature, so soon after the universe began, that researchers have described the finding as one of the most disruptive results in the telescope's history, still not fully explained even years later. Webb has also transformed the study of planets beyond our own solar system. The telescope has directly analyzed the atmospheres of dozens of distant exoplanets, detecting molecules like carbon dioxide, water vapor, and sulfur dioxide with a level of precision no previous instrument could achieve. On a planet called WASP-39b, Webb even detected evidence of photochemical reactions taking place in the atmosphere, essentially catching sunlight actively transforming the chemistry of a distant world in real time. That kind of atmospheric detail has become one of Webb's signature scientific contributions, offering scientists their clearest picture yet of what conditions might actually be like on planets light years beyond our reach. Closer to home, Webb has also turned its instruments on objects within our own solar system, including detailed new observations of Uranus that mapped the vertical structure of its upper atmosphere for the first time, and continued monitoring of rare visitors passing through our solar neighborhood, including interstellar objects that originated from entirely different star systems. All of this context matters when looking at the new Centaurus A images, because it highlights exactly what makes this particular anniversary release so fitting. Rather than showcasing an entirely new type of discovery, NASA chose to demonstrate growth, returning to a well-known, well-studied galaxy and revealing just how much more Webb can now uncover compared to what was possible mission. It's a deliberate reminder that Webb's value isn't only measured in brand new discoveries far away, but also in how much deeper it can now see into places astronomers thought they already understood. Researchers involved in analyzing this new data have emphasized that the work is far from finished. The newly resolved stellar populations within Centaurus A represent a rich, largely untapped dataset, one scientists expect to continue studying for years, extracting increasingly detailed information about star formation history, the galaxy's dust structure, and the ongoing relationship between its central black hole and the anniversary image marks not an ending, but the beginning of an entirely new phase of research into one of the most scientifically valuable galaxies in our cosmic neighborhood. 4 years after its first images stunned the world, Webb isn't just continuing to deliver groundbreaking science. It's revisiting galaxies astronomers thought they already understood, and revealing that there's still an enormous amount left to learn, hiding in plain sight, waiting for exactly the kind of clarity only this telescope can provide. If this story gave you a new appreciation for what Webb has accomplished in just 4 years, make sure you're subscribed, because there are more incredible discoveries like this coming every week. Hit like, drop a comment, letting me know which Webb image is your favorite so far, and I'll see you in the next video. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other, a silent standoff that has been running for billions of years. The surface itself holds its own separate mysteries. In a region researchers named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system. Tall rows of jagged ice blades, some reaching more than 1,500 feet high, made of frozen methane and arranged in long parallel ridges. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged frozen terrain circling the dwarf planet. South of that famous pale, heart-shaped plain, two enormous isolated peaks rise out of the surrounding landscape, and researchers still cannot fully explain them. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes here on Earth. Both mountains have deep depressions at their summits, ringed by fractures with lumpy, uneven flanks that closely resemble cooled lava flows. Except, of course, there is no molten rock on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted, not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today, the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept in a liquid state by the slow radioactive decay of elements inside Pluto's rocky core. The evidence for this is not a photograph, it's a pattern. Cracks and ridges across the surface line up in ways that fit what you would expect from a subsurface layer of liquid water, shifting slowly beneath the crust. And that famous heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons. If a body as small and as cold as Pluto turns out to be, hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed. Right now, there is no way to confirm any of this directly. There is currently no funded mission planning to send a probe back to Pluto, largely because the journey alone would take the better part of a decade, and outer solar system exploration has rarely been treated as a funding priority. For the time being, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings back into its field of view, adding another data point each time, and almost always making the overall picture stranger than it was before. Here's the detail that tends to stick with people longest after they hear this whole story. Pluto is not unique simply because of its location. It sits inside the Kuiper Belt, a vast ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects wider than 60 miles, along with an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. And unlike the much more familiar asteroid belt sitting between Mars and Jupiter, the Kuiper belt remains almost entirely unexplored territory. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents. And even that mission only managed close flybys of two objects, Pluto and a much smaller, more distant body nicknamed Arrokoth. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath a shell of solid ice, there is no obvious reason to assume it's the only object out there doing anything like this. It's simply the one close enough and bright enough for our current instruments to study in real detail. Nearly everything else scattered across that same enormous region of space remains almost entirely unobserved. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of new questions that scientists are still learning how to properly ask. Out past the orbit of Neptune, in the cold and the dark, there are trillions of other worlds we have barely glanced at, let alone studied closely. And if one small, formerly dismissed dwarf planet was hiding this much complexity underneath its surface, using nothing but a telescope that was never even sent there, it's genuinely worth wondering what all of those other distant worlds might be hiding too. If stories like this one, grounded in real, published research rather than exaggerated headlines, are what you want more of. Subscribe to this channel and turn on notifications, because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I'll see you in the next one.